Works? Yeah. So, good morning, everyone. It's great to be here at Selenium and Appium Conference 2025. Thank you for joining this talk. My name is Oscar. I work as key architect at SUSE, and I spend most of my career working on test automation and DevOps topics, always looking for ways to improve quality engineering. Today, I want to share a testing approach that speeds up feedbacks to developers and optimize the execution of tests. Works? Yeah. So let's start with a common frustration. You make a small change, you open a pull request, and then you must wait hours for your test suite to finish. That's painful, right? So in my project, we use it to run all tests when we run a pull request. So we didn't take into account we didn't take into account if they were actually relevant to validate the product changes. But that way, we ended up testing parts of the system that weren't even affected. The result: wasted time, wasted resources, and a slowed down development speed. Modern development moves fast, and we need efficient testing and fast feedback. However, running tests on every pull request, it could be incredibly slow and resource intensive. Here is a visual representation of what I mean. So, testing features that haven't been affected is like being in front of a red light when there is no traffic. We need a way to make this process smarter. So, I propose an idea. What if we could dynamically select only the most relevant test? Okay, but how can we decide which test would be meaningful? So imagine our application is this puzzle where each piece represents a component interacting with others. We know we have made a change on the orange component, and we know that some of our tests covered this component in some way, like test A or test B. We also know that other tests have nothing to do with this, like test C. Okay, so instead of testing everything, if we understand the code of our application, and the code of our test, we can identify the tests that cover the affected component. Perfect. Then the plan now is to design an automatic mechanism to carefully target those tests that will provide valuable feedback. Okay, let's figure out how to design a solution for this idea. I'm going to propose today a solution based on code coverage tracking. Let's break down how this works. So, we start by recording which parts of the product code are executed while we run a particular test. So, capturing this data helps us to determine the relation between our test and the product code. When processing the code coverage data, we can decide the granularity we need in order to map a piece of code with a list of tests. So I recommend not mapping coverage line by line. That would not be optimal to store and to process it, and it's going to badly scale. Instead, you can map it by method or even by class level. If we know exactly which methods are triggered by a test, we can be much smarter deciding when to run the test. But my suggestion is that you start mapping only by class name or file name, so you get an idea and refine it if you need. Once we have this map, we can link code changes to the most relevant test. Okay, now that we know how to build this map, we need to store it somewhere. When we process a new pull request, we want to quickly find the test that needs to be executed. If our lookup process is slow, we might lose the benefits of targeting only the most relevant tests. So our solution should be easy to maintain and scale with growing test suites. So using a lightweight storage system like a key value database can help keep things fast. Cool. So now we need to build a pipeline to orchestrate all of this. So the idea is to periodically, weekly, for instance, we will be updating that code coverage report with the latest content from the base code and from the test code. So we first build a product to ensure we are testing on a stable environment. For that, we will use our base branch, so the branch that we use, that we will be merging our new pull request. For instance, the main branch. And then we deploy it. Once we have this deployed, we run the product configuring the code coverage tool. So it's ready to record when we run our test. And next, we run the test suite. When we run this test suite, we need to run it every test one by one, so sequentially, because the idea is isolate all the code coverage tracking per test. So we run the test, and then using the code coverage tool, we will be doing a dump of the generated code coverage data that we had during this time that we run the test. Then we reset the memory data on the code coverage tool, and so this is ready and clean for the next test to run. And we generate the XML report. This XML report will be generated through the binary that we had on the dump, and we parse it. So the idea is parse this code to generate a set of key values where every key gonna be a piece of code, and the value gonna be all the tests, a list of tests that will be triggering that piece of code. And finally, we store it on database. Okay, so now that we have covered how to generate the map, we need to think about the validation of the pull request and how we select the relevant test. So we have this other pipeline. So at the moment a developer opens a pull request, we want to kick off our test selection process. And here is where we traditionally run all tests, and that's what we want to speed up. So the first step is to analyze which files have been modified on the pull request. And also if we have a more granular map, here we can also process the code changes and identify extract the modified methods. So then, once we have this, we can use our key value store, key value database, and we determine which tests cover the code changes. With that, we can run the selected test, and once the test finish, the results are reported directly on the pull request. If everything passes, the developer knows the changes are safe to merge. If a test fails, they can see which test failed. Here. Together, along with application logs are stored as an artifact on the pull request. So the idea is that developers will be able to download these artifacts and debug these logs and seeing the test report and iterate over their changes until they have a pull request that have all the tests passing. If the test fails, we can also configure our platform to block the merge until the issue is resolved. This prevents bad code from reaching main branch and keeps CI tests stable, reducing wasted time reviewing test reports. However, blocking merge should be used wisely. as it depends on the flakiness of your test. I recommend excluding any test labeled as flaky. Otherwise, the team may face false alarms, block development, and make this approach impractical. That's the full picture of both pipelines, and they are only connected by the key value database. Okay, so now what tools can we use to make this happen? So to implement the smarter selections, we need tools for four main tasks. Sorry, track code coverage, store and retrieve key values, run a pipeline combining this task, and last, run a workflow to validate the pull request. So let's go through them one by one. So in my case, my product is made mainly in Java, so I use JaCoCo. JaCoCo is one of the most common tools for measuring code coverage in Java. In my case, I can configure it through Tomcat. So this tool provides detailed reports on which parts of your code are exercised during the recording. If your product is made on a different language, there are similar tools for tracking code coverage in almost every language. Like on JavaScript, you have Istanbul, on Python, coverage.py, on .NET projects, you have Visual Studio Code coverage, on Ruby, you have simple code, Go, you have a built-in option, which is the cover mode, and so on. So, next, where do we store our map? For this, Redis is an excellent choice because it offers quick queries and it's lightweight. Also, you can find similar alternatives in your public cloud providers. For CI/CD automation, Jenkins is one of the most widely used tools. We can integrate the generation of the code coverage report and mapping it using Jenkins. I'm using Jenkins in my project because we already had all the CI made on Jenkins, so it was just following the trend. But you can have other alternatives like GoCD, Concur CI, or Drone CI. Finally, for your pull request, if you are using GitHub, GitHub Actions can handle smarter selections very well. But this approach is not just limited to one repository hosting. You can run smarter selections on Gitea, GitLab, Bitbucket, and others. So, now that we understand this proposal for smarter selection, let's move on a real-world implementation. This is an adaptation of what we proposed here for the project I'm currently working on, Uyuni, which is an open source system management solution for Linux distributions. So, give me 1 second. Okay, so let's start configuring, setting up the code coverage. First thing, I'm not sure if, yeah, I think it can be read. So first thing that we do is configure our Tomcat. We will be creating a new configuration file, this JaCoCo agent.conf. What we do here is override the Java ops, so the JVM settings, and we will be running, before we run the product, we will be attaching a Java agent that's going to be the JaCoCo agent, which is a jar file that we will be showing later. And we can pass some parameters. On my case, I pass 2 parameters, the includes, which you have an includes and excludes, so you can track only certain Java packages. You don't need to track everything if there are some dependencies that you don't want to track. And then the output. In that case, it's the Java agent is listening in a port because there is another tool, the JaCoCo client, that will be able to do calls to it, to do the dump, and to do reporting and some more stuff. But there are more options that you can see on the link that I share with the documentation. Okay, then My test environment is deployed using Terraform. So at the end of the Terraform file, I have a resource that's using a provisioner file. And what I'm doing here is inject the configuration file from Tomcat that I was explaining before. I'm adding it inside the Podman volume because Tomcat and our server are running both inside a Podman container, so that's the way we can access there and add this file. And now we move to the Jenkins pipeline. So on the Jenkins pipeline, after we run the product, after we deploy the product and the test, and before we run the test, we have this stage, the prepare JaCoCo tools, where we will be downloading a version of the JaCoCo agent and JaCoCo client, or those tools, and we will be storing somewhere that's accessible from Tomcat. And then that's key. This is very important. We need to download all the source code from the project, from Uyuni. We can do this with that kind of link on GitHub. You just have this, and it will download the last version from the master branch, which is the branch that we are using for the base branch. And then we just download this and extract in a directory that is going to be accessible from JaCoCo tools. Finally, we will be restarting the Tomcat service, so it takes into account the JaCoCo configuration that we added. And now we move to the last stage on the Jenkins pipeline. So when we have all executed for the code coverage pipeline, we're going to be collecting all the code coverage reports that we made individually for every test. We merge all of them. And the idea is to generate a unique report on HTML that will help to see the overview of the coverage that we made during our test suite in the product. That it's also something useful for the team. So this is an example of the coverage report where you have all the list of Java packages and the different coverage that it has and other metrics. You can go deeper and go at method, at class level for a Java package. And you can go even deeper and go at methods level on a particular class, like this list serialized. And the deepest you can go is to the code. You go to the class, you will see all the green lines are the lines that have been covered during the test suite, and the reds are the ones that are missed. Those in yellow are because are conditional, so some branch has been covered, but the other no. Okay, so now let's move to the implementation of how we made the code coverage tracking. So for that, explain that our test framework is made on Ruby using Cucumber on top of it. We are also using Capybara, that is using Selenium WebDriver also. But let's focus on the class. I implemented this class, the key value store, that basically what it does is do a connection and facilitate the communication with Redis. So we created a Redis instance to connect to Redis, and we had two methods, add and get, just to store and retrieve the key values. Then we have this other class, code coverage handler. This is where we make the real work. So after we run a test, we explained all these different steps that we need to have to process the code coverage. So on this handler, what we do, we have two methods. The first one is JaCoCo dump, that does these three steps. So first we dump all what we had been covering, recording for individual test, and we reset the in-memory data so it's prepared for the next test to run. And then using the sources plus the class files, we can generate a report that in this case is going to be also on XML, not just on HTML, but also on XML. And last, what we do here on that method is because, well, all of this is running on the server, but we want to process this XML on the test runner, so we just move that file from one place to the other. Then on that same class, we have this other method, the second method, which is the push feature coverage. What we do here is we're going to parse this XML file, finding all the classes that have been covered, and if we find a match, then we're gonna store a key value where the key is a class path, and on the value we have the cucumber feature, so our test. We store this on Redis, and then we have a kind of wrapper helper method that have the combination of these two. And in Cucumber, you have at least on Ruby, you don't have an after feature, but you have a before a scenario and after all. So we are using a trick here on the before a scenario, and what we do is we can know if it's the first scenario on a feature, and what we do is before starting that new feature on that first scenario, we process the code coverage of the previous feature. And for the last feature, we just use the after all that we're going to be processing the last feature. Okay, so this tool is a handy tool that is easy to install together with your Redis service or wherever you want. Just Redis Commander, it just helps to browse the map and see all the content you have there. It can be useful when you are developing this or you want to check something. So here an example of a class, the list serialized class, and all the list of tests that have been triggered triggering that class. Okay, now we move to the GitHub Actions and the part of the pull request. So first, we need to configure some secrets. So we want to do a connection on Redis during the pull request, and we don't want that the user and password are public and people can access. So you need to configure secrets. For that, you go to your repository, you go to settings, secrets, actions, and then you can add your values that are going to be used inside your GitHub Actions. Then we have this JavaScript, test covering pull request JavaScript. That what it do is this lookup of the different tests. So first it's gonna have passed by parameter all the changed files, that in our case are all the Java files. It does a connection with Redis, and then it do that lookup to look for every class path, all those tests that can cover that class. We collect all of them, we join them, and we just we log in console, so we can use it on the next step on the GitHub action. So this is the main workflow. We have several workflows chained one with the other. The main workflow is the test coordinator. What we do first is with the help of another GitHub action, we obtain all the changed files and we filter to get only the Java files. And then we will be calling the JavaScript that I show to get all the tests that gonna cover our pull request. Then here, this is just something that we made. It's an example of the implementation because it is something that we made in our project. The idea is that we will not be executing always the recommended test, but it's gonna depend. If we have no recommendation, so zero test, we're going to run the full test suite. And if we are between 1 and 30, we run the recommended test. But if we have more, we decided to run the full test suite because we thought that was too risky, and we prefer to just run the full test suite. So we made that kind of selection here, and we have a variable that is going to be an output that we can use for the next workflow. Then on that test coordinator, we have two jobs, the recommended and acceptance jobs. Those jobs will be calling another workflow, and we will be passing the skip option to choose between one workflow or the other workflow, the recommended test or the full test suite. And we're going to pass also the recommended test in the case of the recommended workflow. So the list of tests is going to be here. Okay, now let's focus on the workflow of the recommended test. Here we're going to be having the recommended test also included as an input, as an output also, because the idea is this workflow is going to be calling another one, the test base, that is the one that really runs all the different steps to set up the environment and prepare it. We will pass also this input.test, which is the Apache script, that what we do here is run a rake task that runs the Cucumber test. So it's all a bit, but yeah, I will not go to that detail. And then on the test-based workflow, we have, first we parse that list of tests and we convert it to YAML file, because that way our rake task can use it. And then we run our core tests. Our core tests are just tests that make some prerequisites. It set up, it create a user, and it create an organization for the app. So it create several things that we need before we run the actual test. And then we run the acceptance test. That here, as you see, we are running a Bash script, which is the inputs.test. That is where we will be able to select recommended test or the full test suite. Now I'm going to show you a pull request where I made a change on list.deserialize.java, just an example with changes. And the workflow will look like that, where we are getting the changed files, the Java files. Then we will be calling the JavaScript that will obtain the list of recommended tests, and the list that appears there is exactly the same, that one that we saw on the Redis commander. So it fits well. And that's the overview of the whole workflow. Here you can see that it's running at that moment the recommended test. But you can see also that there are acceptance tests that are green. In fact, they are green, but they are skipped. So the thing is, they are all those tests to be able later to block the pull request. What we do is run just one step when we skip, that it's gonna show it as green, this other job, and the rest of the steps we really skip. So that way this unblock us to be able to block the pull request with the status checks with these things. Okay, so once the test finished, we have a Cucumber report. This Cucumber report is uploaded to the reports cucumber.io during 24 hours. And to do that, we need this environment variable, the Cucumber publish token, that you can generate and also add it as a secret. And then when you run the Cucumber command, you need to include this, you export this, and then it takes it into account, and it generates a Cucumber report like that one, where you can see the screenshots and all the scenarios failing and running. and so on. Here, in our case, we still have a lot of them that are skipped because GitHub runners run on a unique Ubuntu container, and for the nature of our project, our product, we have network features, and we have some stuff that we still were not able to migrate here, but we are working in proof coverage in that sense. And this is a pull request that fails. So I just added a scenario that we're gonna do is try to find some text that it doesn't exist. So the recommended test fails. When a recommended test fails, we get the server logs and the client logs that are all the Linux distributions that are registered to that server, and we upload all the content as artifacts so the developers can download them and work with them until the pull request pass. And last but not least, the status check required that it helps us to keep the pull request block. So as you can see here, we have this button disabled. You are not able to merge your pull request. Or we do this. This is easy. You go to settings, then you go to rules, rule sets, and you add a new rule set that you can disable or enable to maintain it, and you select on the target. In my case, we only have a default that it's our master branch gonna be used, and then if you go below, you have a checkbox, which is the required status check to pass. You need to mark this, and then, well, in your case, you maybe only have the recommended test, but in my case here, I made this divergence that you can run or the recommended test or the full test suite. So the idea is that we need to pass all these status checks, and those that are skip, they're going to be green because of the treat that we made. So that was all the overview of the implementation that we made on Uni. And the next steps are a Google Summer of Code proposal that I'm going to be mentoring this summer. We already have an application from a student, and the idea is research if we can improve the test selection process by using AI. So we'll be processing the commit history. We will be also trying with the past reports to track past failures, generating dependency graphs. We will keep using the code coverage data on this map. With all of these and maybe other things, we will design a machine learning model and see if it's improved. If it's improved, maybe we can integrate this and maybe we can have another talk. So that was all. Questions? I'm happy to.
Hello, thanks for the talk. Really interesting. I need to filter because I have too many questions, so I will only do one. How do you measure the success of this in the sense of the test that you selected, did actually prevent bugs, or actually the other way around? Like you selected some tests and there was a bug in the end.
We don't have any measure for now. This is something we added this year. So what we do is collecting feedback from developers, especially in the sense of if when they merge their pull request, if they find that was some issue. But we don't have any kind of metrics about this for now.
And do you also, like, you run tests in the pull request and then when you merge to master, or only in the pull request phase?
When we run the test on the pull request, we are checking out the code of the pull request and rebasing with master code. So in fact, the code that we are running is going to be the same one that at the moment we merge.
You merge, yeah. Because we are doing something similar, and we are selecting some tests in the pull request to accelerate that. But when we merge to master, we also execute the full suite.
Well, We run, we have internally, just that's not on the GitHub Actions, but internally we have a CI test suite where we run periodically, a bit more than daily, but all the tests from the master branch. And then that's what we, in fact, want to stabilize and start not wasting that much time, because CI test suite was having threads so often that we, QA squad, spend a lot of time reviewing these test reports. So covering these tests on the pull request, shifting left, the idea is to help us to have master branch stable.
Thank you.
Hi, thanks for the presentation. Wanted to know, do you do this approach on all testing levels?
We do this with end-to-end tests, so with the Cucumber test suite. And with unit tests, we run the unit tests on every pull request also, but this special thing we made only for the Cucumber test, because basically they take a lot of time. The unit tests, they are kind of fast, but those, we are using a lot the UI interaction, so it takes hours.
So in the end, you generate a JaCoCo report of the end-to-end test coverage. So do you merge this report with the report of unit test to get the actual coverage via the test-wise, or you don't?
We don't, but could be interesting idea. Yeah.
Like, because we do same with unit plus integration tests. The approach is plus minus the same, but here we are having a problem of test duplication, and we figured out that after the statistics, we figured out that JaCoCo report, with JaCoCo report, we figure out that some parts of the code are being tested and in integration level, in system test level, and on unit test level, and testing the same thing. And we reduced the tests cut like maybe 20% of the tests from system and integration tests. Yeah, and this code coverage integration, yeah, it's really helpful from different angles.
I must admit that our test pyramid it's inverted a bit, and we have a lot of end-to-end tests, and the team relies a lot in end-to-end tests that we don't have that many unit tests. But yeah, it's something we also need to improve. Yeah.
Thank you.
Yeah, this was really interesting. This is something that we've tried to implement many times at our org as well. But one of the issues that we've run into is when a developer changes a line of code in something that is being executed or being run in every single test. So let's say like an index file or something like that. Have you ever encountered that, and how have you fixed that problem?
We don't fix, we just run the full test suite.
You just run the full suite at that point?
Yeah.
Okay.
That's why we also have this, that if we have more than 30 tests, 30 recommended tests, okay, let's run the full test suite, because it can affect to other places. So, yeah. And with AI, we want to also play a bit with all that part I was explaining about dependency graphs. Because, yeah, might be some hidden thing.
And how often are you updating that code coverage? Are you doing that every night or on every PR?
Every weekly.
Every week?
Every week, yeah.
Okay.
Yeah. We don't do every day because we don't think we need to go that far.
Just a quick question. How much
Well, if you run the full test suite, it used to take, well, we are parallelizing also the full test suite in 5. So the thing is, the time would not be that much, but the problem is the resources, because what we do is run 6 full environments that in our case is a bit big, because we have all the Linux distributions plus the server plus all that. So what we gain a lot is about resources, but you can also speed if you run less tests. But it's true that there is some part that you can't reduce, which is the setup, all of this environment and all these pre-requirements, that this is hard to reduce. So you will need to keep this time. But yeah, this helps on reducing resources, and depending on your test, it will also reduce time. It depends on how big is your test suite. If you have a big test suite that has a lot of features and it takes 2 hours to run, and you need a lot of resources to parallelize this to make it faster, well, then you will gain more. It depends on your case. But in our case, that it's a big one. The one that we run for master branch on CI internally, it's 6 hours or so. So yeah, it's a lot. And that way, we can reduce like 5 times.
Hello, thank you for the presentation. Based on the code that you have shown us before, I saw that when you do the mapping between the scenarios and what code coverage they get, you execute them serialized, like one after the other,
Yep.
right? And you have talked about, just in the previous question, about an execution time like 6 hours. So is this parallelized? The 6 hours are for parallel tests?
So we have the CI test running for master, but this is one pipeline, and then we have a special pipeline, Jenkins pipeline, running weekly that in fact takes a bit more, because as you have this Java agent attached, all goes even slower. And on that case, we need to run one by one, sequentially. We can't run in parallel, because otherwise we'll need to also run JaCoCo tools for each one. You will need a new environment for each of them. So
Yeah, that was basically my question. If this could be executed in parallel when you do the mapping, that was my question.
you can do, but it depends on your project. If your setup of your environment is not so big, then maybe. So you do with an environment that is all containerized, that is fast. But in our case, so this project, what it does is we need to register Linux distributions that needs to be on virtual machines. We need to deploy all these virtual machines plus the server, and all of this is a lot of resources, in fact. So.
Thank you.
Hi, Oscar. Nice talk. Thank you very much. I like the simple and clear way you did it. So my question to you is, in your opinion, when you came up with this test strategy, was mainly to complement or to replace the unit test coverage for the team?
No. So it was to try to speed up the time that we take and the resources that we consume it on the pull request. Because on the unit test side, we did not have that many, and they were kind of stable. They run them on local developers, and also it's part of the pull request. But I was focused completely on end-to-end tests only. Yeah.
One more question. That's all.
It's a great idea. One question I have is, so we have this key value pair, right? So where you are adding the code and the tests that we have to run. So, I mean, how are you managing that thing? So there might be huge lines of code. So how are you managing that thing? It's a big database kind of stuff, right? So how are you managing that?
So the idea is, if you try to do it line by line, that's going to be impossible. It's going to be hard. So what we do is, at that moment, the implementation we made is just by class path. So you know that class going to be triggered by that test. We don't go with more detail, but if you go with a method, it might be better. But for us, it was enough just to know that that class has been covered at some point for a test. So at least we risk less if we do that way, because we will be maybe testing some things, some classes, we will be running some tests that will not be covering the changes maybe, but you have less risk. So that's why we prefer to just have the by classes. So our map is class path and the list of tests.
Did it take much time? So how much time did it take, like this, for this mapping at all? I mean, only for this mapping, how much time did it take for you to do that?
It's the time that it takes the test suite. It's around 6-7 hours.
Oh, okay. Yeah.
We run this weekly, nightly. I mean, on night every week, and that's all.
Thank you.